Hello there. I'm making a second video. This is number 2 on getting started with C. Now, if you're just hopping in and this is the first one you're watching, there are a couple things I want to say before I point you to this one, the intro to the C programming language. So there are a lot of tutorials out there for C, and most of them aren't so good, to be honest, on YouTube. That's part of why I'm doing this. But I would say most people watching this one will probably say that I talk too much about the history. It's not all about the history, but of the hour and a half, maybe I spend like 30 minutes talking about various things. For example, I think you should learn what Ubuntu is, what Linux is, what Unix is, what an IDE is. These are just sort of, I would say these are general computing, if you're some kind of professional in the computing world, these are just general things you should know about. And one thing that I've noticed is a lot of people are very confused about the difference between Linux and Unix. Those are totally different things. Unix is proprietary. Linux is FOSS, or free and open source software. So those are very different, and I've seen people just totally confused. People saying in comments on YouTube, saying things like that Mac OS is built on Linux. Total nonsense. They were actually, originally Mac was built on top of something called BSD, which is something else. But I actually mentioned even BSD here. Well, BSD was from Berkeley. Don't worry about it. But, okay, so, I do spend some time talking about sort of the context here. And I do spend some time talking about what kind of person should learn C. Does it make sense as a first language if you're interested in programming? For some people it does. I would say not for most people, though. So I talk about that. Let's see. I want to talk about the most important thing for beginners here real quick. The most important thing for a beginner, or the hardest thing, the biggest obstacle right away, is just making your first program and running it. That is much harder than, like in this lesson today, I'm going to get into, like we didn't do much actual C programming in that lesson or whatever, tutorial. So, but that was intentional. I wanted a very light introduction where I'm mostly talking, but I do show how, if you're on Mac, Windows, or Linux, how you can get started actually programming C. But I might have missed a couple of details, which I'll talk about in a second. So just stick around for a bit if it doesn't bother you for that. But yeah, I think the biggest obstacle is, and this is kind of often true in programming, like if you're starting, I remember one of the first languages I tried to do was PHP, which is absolutely, do not start with PHP. That makes no sense, because that's that is like a full stack web language. Totally the wrong platform to start with. But yeah, that's one of the things I started with, and I had no clue what was going on, because most of the tutorials often assume a lot of background knowledge. They kind of assume like you already kind of know what PHP is about and sort of the context around it, why you would use PHP. So that's a mistake in a lot of cases. And this is actually just a general problem with teaching, because, I started learning C maybe like 7 years ago or something. So a lot of those really basic things, like those basic questions, I might sort of fly by. And this is just always going to be a problem for people. And sometimes people use terminology that they forgot to explain, So this is always going to be a problem with teaching, why it's hard, and why a lot of teaching material out there doesn't do such a great job. So including my own stuff, I'm going to have some problems there, but please do leave a comment if you have any questions. Now, so that's this one. So this is horizontal format, whereas the other C stuff I've done so far is vertical. It gets less views with the horizontal format, but that's okay. I wanted to, I think it's overall a better thing if I'm trying to teach something to use the horizontal format. And then I can point people back. And maybe it looks like I might be sort of making a tutorial series here. as I go. Okay, now so again, most important, the biggest obstacle in the beginning is just getting a C program that you wrote running on your system. That is a serious obstacle because there's all this confusing stuff. First of all, how do you write the code? How do you compile it? How do you execute it? That is the biggest obstacle in the beginning. Once you get past that, it's actually smooth sailing for a while until you get to more complicated, sort of conceptually more complicated things. And then also what happens is you sometimes run into technical problems. In here I mentioned 2 technical problems I had just setting up Ubuntu. In this most recent video was 3 hours ago. I ran into a bunch of problems trying to get a debugger working. I tried 2 different debuggers, both catastrophic failure. So in the last few days, I've spent probably 2 hours trying to get debuggers working and failing. I'll continue to try because it's an important thing. But anyway, so first obstacle, just getting your feet on the ground, walking, getting started. That's actually a huge milestone if you just get there. You kind of get the keys to the car, and now there's a whole world open for you. Second obstacle, you will probably run into technical problems at some point. And to be honest, that's just a hard reality, hard truth of programming. It's the thing I hate the most about programming, that I dislike the most about programming. You will run into technical problems. That's kind of the job description, and it sucks. That's just reality. But the third obstacle is going to be kind of more later on when you run into, there's some things that are conceptually a little complicated in a language like C, and that is reality. So 3 kinds of obstacles you're going to run into. Then I didn't, in the last video, I forgot to complete my discussion of what is Unix. So I'll get to that just next. There's a bit of stuff about installing Visual Studio on Windows. So if you're on a Mac, this is a non-issue. But on Windows, first of all, there's Visual Studio, then there's Visual Studio Code, which I talked about previously. Those are 2 different things. That's already a little confusing. But if you ever install Visual Studio, it'll give you a bunch of options and a bunch of boxes you can click to add a check mark to install different things. So there's a bunch of options. Make sure that you check all the boxes related to C++. So you might think, I'm just doing C, I'm not doing C++ yet, so I'm not going to do those. No, that's a mistake. A mistake that's very easy to run into. I ran into it, caused me a lot of problems. Check all those boxes for C++. If you don't do that, and then you try to do some C programming in Visual Studio, what will happen is you'll get a weird error about not finding header files on your system, and you'll Google it, and Googling isn't really going to help you, and you're going to be banging your head against the wall. At least I was for days, and then I just decided, well, I'll just reinstall Visual Studio, see if that works. Then I checked all the C++ boxes, then I had the header files. So that's just the thing, if you're doing Visual Studio. Now, Visual Studio is a full IDE, that means interactive development environment. So it has a lot of bells and whistles. It also has a lot of added complexity. And when I was learning programming in the beginning, like 10 years ago, most of the tutorials out there were in IDEs. And it's okay if you find a tutorial series that you like and they're using an IDE, go with it. But it kind of bothers me that those tutorial series, they almost never teach you how to free yourself of the IDE, how to escape it. And that can be a challenge. I remember, I think I was like 2 years in, when I just got sick of the IDEs and wanted to program in the terminal, which is what I show you how to do here. And it took a lot of work figuring out how to do that, because most of the tutorials weren't talking about it at all. And so if you install Visual Studio Code also, let's see if I can bring that up. Here it is. For C and C++, you might want this extension. Sorry, you click here if you do this. And this is on a Mac as well. There's this extension I forgot to mention. You can install that here. and you probably have to restart. But I'm not sure if this is strictly required. And then I'll say, somebody who has some experience with this stuff, help me out, because on my system at one point I installed MinGW, and I'm not sure. Yeah, I'm not using it actually, but for people who want to do this work in Visual Studio on their local system rather than WSL, let me know if you needed to install MinGW. I'm honestly not sure. I have it on my system. I've had it here for years, so it's not a fresh install of Windows, so I'm not really sure about that. Anyway, I'm doing this stuff in Ubuntu, mainly in the terminal, but also I have set it up so that I can run Visual Studio Code from the terminal here, which is pretty useful. So I could do that for the current directory. I'm going to do it for the C tut here, and it will open Visual Studio Code here, which I find pretty useful. You know, it's nice. It's kind of beyond this. This is a sort of a text editor / IDE thing. I mean, Visual Studio Code is kind of in between. It's sort of in the space between text editor and IDE. Again, the IDE is like pretty heavyweight. It gives you lots of bells and whistles, lots of different things, but it's sort of, on the one hand, it does too many things for you sometimes. So people who learn only in the IDE, they actually don't learn some of the real basics, even for years, which is actually disappointing, to be honest. So it's good to learn how to build things and run them outside of an IDE. And then text editors are just text editors, so they're literally just editing text, and they're not going to give you a bunch of fancy things like a debugger and all this stuff. I haven't explained what a debugger is. We'll worry about that later. Sometime later. Okay, so here I'm in this Ubuntu terminal, and I'm going to make my camera a bit smaller now. And so I talked about this in the previous video. Now, some of you can figure out, for example, whether you're on a Mac or Windows, if you don't want to bother with the terminal. First of all, I would recommend, just if you're interested in programming, if you want to be a programmer, I'd recommend learning how to use a terminal, because you're going to be at a disadvantage if you don't know how. But you could, say, go here to new folder, and you can do that on Mac too, obviously. And we can make a folder here, and I'll just call it whatever. C tutorials, for example. And I could open here, and let's see, new. So it's difficult to just make a random arbitrary file. You can do a text document. Let's see, can we just change the extension? I think it should be okay. Do you want to change it? Yes. And I think you can do something similar on a Mac. So you can do stuff like that. And then what you could do is you can just load up VS Code and go to File, Open Folder, and then navigate here and open it. So you don't, strictly speaking, you don't have to use a terminal. You can also go here and open a new terminal right here in VS Code. Now, it's actually running PowerShell, so there's a slight difference from the terminal I'm using. I'm using Ubuntu. Most of it will be the same, though. I think it's honestly probably it's going to be mostly the same. Another thing is that you're going to have to figure out how to, if you do this route, you're going to have to figure out on your own how to compile. Though, let me think. Yeah, I would just Google it, because I'm using a compiler here in Ubuntu, but you'll be using a compiler, you'll be doing something else. So I'm not doing that. Well, let's see. Does it have, for example, does it have GDB here? Yeah. So I guess, so it's a little complicated, because here I'm running this on my WSL system. So it seems to have GCC and GDB. GCC is my GNU compiler, GNU C compiler. GDB I haven't really talked about, but that's a GNU debugger. Don't worry about that right now. However, so if I open the terminal, let's see, if I open this, let's see if it has it. I'm not sure if it's going to have it built in here. Of course, we don't have anything here, but that's okay. New terminal. Says it's running PowerShell. If I try to do GCC. No, but the thing is, I've installed GCC in PowerShell before, I think. So it's getting a little complicated. And if you want to go this route, you can, but you need to maybe figure out how to compile things yourself. That's all. But I'm just saying it's viable. There's many, many ways to do things with programming. But if you want to follow along with me, I'm doing stuff in the WSL terminal here. So yeah, nobody said it was going to be not complicated. So I'm sorry about that. But that's just the reality of programming in C. There's some complicated system stuff to learn. Okay, so I think that's all I wanted to start off saying here. And then what I'm going to do for this lesson is basically there's a website called, oh, and I just want to say, so yeah, that's the first video in this series. And then there's these other videos that are vertical, but this is not really easy. This one says easy C coding, but it's easy if you're experienced in C. It's not beginner. So I would say maybe look at this after like 50 hours of trying to do C stuff, then here's okay. Maybe I shouldn't have called it easy, but honestly, it kind of is. The stuff in here is actually easy. But anyway, so there's a website called Learn X and Y. It does it for a lot of stuff. It's a bit advanced, so I'll explain it. Learn X and Y, where X is C. We'll type that in. So you can do this for a bunch of things. And these are, this is for programmers. And this is advanced. The point of this website is people who have experience in a lot of languages to quickly learn. Because learning a programming language is not like learning Chinese or Japanese, Arabic, Icelandic, or something like a human language. That will take many years. But learning a programming language, I would recommend in your first couple of years studying programming, you should learn a handful of languages. And once you've learned a handful of languages, then learning a new language, sometimes most of it can be done in an afternoon. It really depends on the language. It depends if you have learned things that are similar to that language before. But in some cases, just in an afternoon, you can figure things out. And that's kind of the idea behind this website. So again, I'm not recommending this for beginners, but I will go through here and talk about some things. Because, for example, just adding things together, well, you'll see how this goes. So one thing it talks about here is it introduces some compiler flags. And I'll probably be bringing this up later. Right now, I just want you to know about it. We don't really need to worry about it. It gives you more... It's actually just more strict. So that when you do something that's kind of bad and not recommended, instead of just letting you continue down that path, which may cause problems later, it's going to be more strict. There's also different versions of C. So one of them is 1999 version, C99. So an advanced user is probably going to specify which version of C they're doing. And this also just is kind of getting more strict, or I think maybe this one gives you more information, possibly, in errors and warnings. Okay, and we have, I don't think I've talked about comments, but if you start a line, let me move this over. If you start a line with 2 slashes like this, it will make a comment, which is just text that does nothing. The compiler totally ignores it. There's also these multi-line comments you can make like this with these symbols right here. Okay. So you're just going to see that I'm going to be doing that. Enum, we're going to worry about later. These sort of defines we're going to learn about later. But I think it's good just to mention these things, then you'll just have exposure to the word. I think is helpful. And we have some includes. So includes, I have maybe done I don't think we did that. Not in that first video. But basically, there's something called a standard library. And the idea is that there's all kinds of useful code. Now, so we'll talk about strings. So strings are basically pieces of text, so words and that kind of stuff. So if you had a username, for example, that would probably be stored as a string. A password probably might be stored as a string, and so on, generally. So a string is just a string of letters, okay? And it's text, essentially. And so there's a bunch of functions. Functions do things, right? So there's a bunch of functions associated with strings, just as an example. There's also a math header file. These are called header files, this .h. So don't worry about it too much, but just know that as we go, we're going to be using useful things, and we're going to be including stuff like this. This one's for strings. This one is standard I/O, so standard input output. And that is going to let us easily print stuff to the terminal. So we're going to be using that. We'll talk more about this kind of stuff and functions and this kind of stuff later. They mention about main. And I'm also bringing this up because some of the audience here may be familiar with other languages. And so I think this is a great, if you are familiar with other languages, this website is fantastic for just quickly learning a bunch of information. Now, we've talked about the main function. Every C program needs a main function, and this is your program's entry point. So it's called main. That's where execution starts. So let's do this. So let me close out. Let me just get rid of some of the clutter on the desktop here. Yeah. And so this is actually all that we had so far. Let me clear this. So we have so again, so this is review now. Hold on. Just closing some things out here. Okay, so review. So what I want you to do is open Ubuntu, or if you're on Mac, open the terminal. And you can always do clear if things get messy like it is for me. I'm going to make this a little bigger. Don't worry about that. I can increase. Oh, the font is pretty big. Oh, that's big. That's okay. That's not bad. So what we're going to do is a little bit of review of the terminal first. And if you watch the first video and like everything is 100% fully understood in your head, then sorry, the review is going to be redundant a bit, but PWD tells you where you are on the system. And if you're new to C, I highly recommend going back and watching the previous video. Again, I kind of just bear with me on it because there's a lot of context, like what is Ubuntu, what is Linux, what is an IDE, what is Unix. Oh, I forgot to say what there's a bit I forgot about what is Unix. So let me explain that. But anyway, I give you a lot of context. I just think you should know that kind of stuff. You should know what Ubuntu is at this point. And so what is Unix? There's a bit I forgot because there's a whole history. It changed over time. Unix used to be it's an operating system, but nowadays it's almost kind of like a trademark or a certification where people like Apple, as the most famous example, they pay money to be sort of Unix certified. Now, why Apple does that is a good question. Why they even care? Like, they could easily just ignore it and do their own thing. But my guess is that Apple might do that to sort of keep their systems under control. Because if they stop being Unix certified, then anything is possible. They could start implementing their operating system in all kinds of different ways. So my guess is maybe they think it looks good to the engineering world. Maybe they care about these standards, and or it just helps sort of rein in control and make sure that what their engineers are doing it sort of complies with certain standards, because that's what Unix is. It's basically a set of standards. And so, contrary to what a lot of people think, Unix is basically proprietary. It is not FOSS. It is not free and open source software. It's not that kind of thing. You have to pay money. Well, I guess it's. I think. Yeah, I think the standards are open, right? But it is not free. You have to pay money for that sort of certification. Anyway, that's my rough understanding. And so Apple is indeed Unix, but we use this term Unix-like as sort of an umbrella term, where it's basically everything that's not Windows, more or less, that follows actual standards and conventions. So Linux is definitely Unix-like. I'm pretty sure BSD, which is more obscure, is also Unix-like, and definitely, well, Mac is actually Unix. Okay, so a lot of times you're going to see, if you are trying to install some kind of programming thing, it will often have instructions that are, there's Windows and then there's Unix-like, or it might say star NIX, star Nix, meaning Linux and Unix. Okay, that concludes the discussion of Unix. So we have pwd, shows us where on the system we are. If I want to go to the very top directory, I can go cd/, that's my root directory. If I ls here, there's a bunch of directories. One of them we could talk about is maybe bin. So bin is for binary, basically. And oh, there's a lot of stuff there. So let's see. We have our vim binary in there. That's cool. What else do we have? There's actually, so a bunch of the Unix commands are sitting here. We haven't learned it, but tr is one of those. Tar, I've actually used on the live stream. That's, it's sort of like zip. It's for compressing and uncompressing files. Sudo or sudo, we've used that. In one of the live streams, I did SSH key gen. So we have all these Unix commands in here, including, well, we have like ls. Yeah, there's ls. So that's interesting. So that's where those are actually located on the system. There's an IP one that flew on by. I've got git is installed here. Not every system comes with git. Here's GCC. Yeah, so we have a bunch of things here. This is a super old school text editor. Do not use that. The echo command we've actually used, though I didn't really explain it. Don't worry about it. Curl is used for downloading things from online. Cron tab is used for automating tasks. CP is for copying files and directories. I don't think I've shown it, but it's a very common command. Chmod is used. Well, that's more advanced. We'll talk about it eventually. It's for changing permissions on files. Like we've kind of seen, there are different users, and there's the root user. So that means there are different permission levels. Like in the previous video, you saw I was occasionally denied access to things. Like when I try to change directory into my root directory, the /root directory, I was denied. So that has to do with permissions. Chmod is used for permissions. Awk is used for sort of filtering or editing text, and it's quite complicated. It's actually technically its own programming languages. It's its own programming language because there's so many things you can do with it. apt is the package manager here on Ubuntu. And yeah, so there's lots of stuff there. So that's /bin for binary. Binary is another word So you'll hear people say program, binary, or executable. Those are all the same thing, basically. It's just a program, something that runs, basically. Although I probably wouldn't refer to these as programs. I would refer to them as either commands or, in some cases, command line tools. It's all semantics. I mean, they're just things that do things on your computer. Okay, so I'm going to cd up. So remember, this is for the parent directory. We go up. And this is what I mentioned, the root directory. So it's confusing because this is the root. I'm in the root directory, the very top of the whole tree or the whole hierarchy of the directory. I'm there right now. And we call that the root directory, but this is also called a root directory. But so to differentiate these two directories, you should call this one /root, this one that I'm highlighting here. And right now, if I try to change directory into there, I get permission denied because I'm not the root user. Okay, and then we've got the home directory. So you'll learn more about this in the future if you're interested in Linux stuff. Not everyone cares. But I can go into my home directory. If we ls, which just lists everything in the directory, we only have one user, which is uv. So we can cd in there, and I'm back in my home directory. Alternatively, I'll just go back somewhere else, like root. At any point, I can just do cd and enter, and I will go to the home directory of whatever user I'm currently using. So if I were root, it would actually have gone to this root directory, the /root directory, actually. But my current user is uv, so I'm here. Okay, and on most of my live streams, I've been working in this C directory. That's kind of for my own purposes, my own practice and review. But in the last video of the introduction to C, and in this video, we'll do the C tut directory. So you would have done that in the previous video, but I'm just keeping in mind some people might be coming here and they're too lazy to watch the previous video, and that's fine. So let's do some stuff here. So I will ls this directory, and it will show that there's just the main.c in there. What we can do is let's use the copy command. My camera dies every 30 minutes, so copy rather ctut, the name of the directory that you're using, whatever that is. And I can actually just push tab here. It will auto-complete, or you can type it out. And we will copy this file, the main.c, into the current directory. Current directory, remember, is the dot. It's just like a shortcut or alias. And now when I ls, we have the main.c in here. Cool. What I'm going to do is I want to destroy this directory. So I'm going to use this rm command, which is remove. Now you need to be extremely careful with this command because it actually will, you could use it to delete your entire system and crash your computer. You honestly could. So it's a very powerful command. You really need to be aware of it because a lot of people try to mess with people as a prank and they'll add advice online. For example, a lot of people have been saying, the first thing you need to do when you install Linux is to remove the French language pack. And they give you a command with this that looks like, to someone who doesn't know much about what they're doing, it looks like, hey, maybe that actually removes the French language pack. But they give you a command that actually just starts deleting all the files on your system, and your system will crash and maybe not be recoverable. So be very careful with the rm command. In fact, just to try to give you good habits, I'm first going to do this, which is not going to work. But let's press enter and see what happens. Cannot remove ctut because it's a directory. So I'm going to press up to go to the previous command. We need to add some options here. So, and actually, let's try without the F. I forget what it does. Usually you do RF. Let's try it without the R, or without the F. It worked. I actually forget. Well, the F is for force. I think actually if we'd had a bunch of files in there, we might have needed to do RF, but because it's just one directory, maybe this was okay. I'm not sure. I just always do this for removing a directory. If you want to delete everything in a directory and all of its contents, do this. Now, if you say, oh, okay, UV is confused about what the difference is between just R option and RF, you can do this on pretty much any command. This is a further manual. No manual entry. What? No manual entry for RF. That's actually surprising. Well, depending on the system, some of them have to have it. There has to be a manual for RM. So I don't know why my Ubuntu instance doesn't have it, but here, I found it online. It exists. It should exist. The man page, we call this, the manual, should exist for all the commands. So yeah, we've got it here. And R is for recursive, so it goes through everything. F is for force. Ignore non-existent files and arguments. Never prompt. Yeah, I'm not sure exactly what the difference is there, but sometimes you have to use it, so I just use it. Anyway, so that's man, that's RM. We've talked about CP here. And CP also, let's see. If I were going to, don't follow along, but if I were going to copy this directory, so my C directory has a lot of files in it. So if I just do CP, C, and then we need some kind of target, so I'll just call it new C. It needs the recursive thing. So we need the option. So I do RF there too, I think. And it worked. Yeah. So now I have this new C thing here. I'm just going to remove it. So let's try without the force here. Let's see what happens there. Yeah, it gives me a bunch of weird questions. So if you get kind of stuck in the terminal, like I want to exit this without, it probably wants a Y or an N, actually. It doesn't say that explicitly, but I bet you a Y will remove it. But there's going to be a bunch of these. Look at that. That's going to be a pain. I can do Control C. This is just generally you need to remember. Control C will exit whatever process you're stuck in. So that's why we use this RF here. And that will delete it. Now I'm also curious, if I didn't do RF with the CP command, let's see what would happen there. C to new CP. New C. Sorry. C to new C. That was okay. But usually I use RF there too. Whatever. So I know it's a little overwhelming, but you'll get the hang of it. So what we've done now, we did copy out this main.c. So it's just practice. You need to practice this stuff. So what we're going to do is we're going to again make a new directory. And I'm going to call it ctut because I destroyed that directory. Though you can call it whatever you want. Now I'm going to copy main.c into ctut. And yeah, that's the command for it. So notice it's a copy. So if I do ls ctut, it's there. And if I wanted to really verify that the contents were there also, I can do cat, which stands for catenate. Whatever, it's a big word. It will reveal the contents of that file. Coolness. And you can think of this, I mean, it's like a relative address. We're in this home directory. And in the directory, and again, folders, directories, same thing, no difference. Just two words for the same thing. In the ctut directory or folder, there's the main.c, and it says cat it out, like show us the contents. Okay. Now this is just terminal output. I can't edit that at all. So, okay. Clear ls ctut. Now, I would recommend, if you want to get familiar with the terminal, maybe spend some time cleaning up your system. Like we all have files and folders that we don't need. It actually can be faster. Once you get the hang of it, it's faster to use the terminal a lot of times to navigate, because I can go, I can go very quickly. Okay, like I go like this, cat out main. So once you get quick at it, then it can be very fast. So maybe for practice, try to spend some time, I don't know, finding files or folders that you don't need and deleting them. Again, be extremely careful with the rm command. Maybe type the thing first without the rf. Because if you type the rf first and then do not do this. If I did this, this starts deleting everything from the root folder. So this is the extremely dangerous command that people throw around on, and this applies for Mac also. People throw it around as a prank on various text advice forums, and you'll see it online. It's basically a meme. If I pushed enter right now, it would start deleting. This does not have access. It's not going to start deleting all my Windows stuff. Hopefully not. I think actually there's some danger of that. So it's extremely dangerous. Do not do that. So that's why I recommend maybe, and there's certain commands, because these sort of Unix style commands can be very powerful. There are certain ones where I deliberately write it out where I know this is not going to work because I don't have the RF part. That's not going to work. Now that I'm absolutely sure that this is the target that I want, then I go back. You will hear stories. Most people have accidentally demolished a machine. I mean, if they do a lot of things with Linux or programming, being a systems admin, that kind of stuff. A lot of people have demolished a machine with this command. I don't think I ever have because I'm extremely careful. So that's my advice. Okay, but I don't need to do that. So anyway, you can clean up your system very carefully as practice. I think is good to you. You'll navigate around your system, maybe copy some files, remove some files, and you'll get acquainted. Let's see what's in this tut folder. We still have main. Good. But I don't need main in my home directory here, so I'm going to remove that. Boom, it's gone. Clear ls cd into ctut ls. There we go. So here's our main. So I'm going to clear ls main. We can cat it if we want. There it is. Clear ls. Look at that. Now I introduced a couple of text editors, Nano and Vim. I'm going to focus probably on Vim or VS Code. VS Code is kind of nice. VS Code is going to look nicer in this video, so I might do that. And yeah, but you can do it. You can follow along in Vim or Nano or VS Code. Again, if you want to open VS Code from the terminal here, you're going to have to Google how to do that. There's some setup. Or if you're on a Mac, you can open up the current directory with this command. And if you're in Linux on WSL here, you can open it up with this. And then, let's see, we can actually go up one. And then we could just take VS Code. We could just drag it in like this. And we're here. So, like here, if I, just to demonstrate it, with my C directory, here it is. This is my C directory. With the ctut directory, I drag it in. Here we are. So that's another way to access it if you want to use VS Code. All right, so now we've got this main.c. So that was all the shell review and a few new things, I think. And that's good. And now if you ever push here, it will create these red dots. These are for the debugger. We don't need those. You just click again and they'll go away. It's not going to cause a problem. But anyway, this is what we had last time. So I'll quickly review what this does, and then we'll learn some new things. I was going to kind of use this as sort of a rubric. We should maybe do printf, I think. You'll notice there int main has more stuff. That's going to come much later. Don't worry about that. And maybe we'll talk about printf and some other kind of lightweight stuff. I don't want it to be too intense. I want my idea is to have a few videos where it's a very light introduction before things get a little more intense. So let's review what this is. So we have a main, and also technically I'm supposed to put void here. I mean, everything works fine if I don't, but this is sort of convention. Void basically means nothing here. So functions, this is a function. They have these little parentheses, right? Well, this stuff goes in the parentheses that are arguments. So it's like a function does something. So imagine the argument that goes in here is like something you receive in order to do something. So for example, let's say that I am a chemist and I turn coal into petroleum oil, but I need coal as input before I can do it. So that would go in here. We would have coal in here, okay, and we would return oil or petroleum. I'm just using a figurative example here, but void basically means nothingness, right? Nothing. So again, it worked fine without this, but as a convention, technically you should have this. Another little random note: some people put void here, which probably works, but technically is wrong. That's convention and specifications. So there's specifications that specify how the language is supposed to work, and they tell us do this, so we do it. That's basically it. There's a lot of stuff like that in programming, but I feel like since I'm teaching it, I should do it the correct way. But you will sometimes see this. Technically it's wrong. Probably it works fine. Don't do it. It's one of those things like maybe it's working most of the time, but who knows, some future compiler might make it not work. Who knows? We don't want to run into those kinds of problems. So we do it. We're nice little boys and girls, and we do what we're told. And we put void here, and we put int here. Now, this is a function. So again, every C program needs a main function. This will be the starting point. It starts after these curly braces. Some people just have the curly braces up here. It doesn't matter. It's a preference. And yeah, so what is this doing? And also the int here refers to the output of the function. So I said if I'm a chemist and I output oil, petroleum, oil, whatever, then the type here, I guess, would be, I don't know, fossil fuel. It's sort of meant to be more general. Obviously, I'm not being literal. This is figurative. But if we were taking in coal, doing some kind of process, which there is an actual process to turn coal into oil. That's why I'm using it as an example. Of course, petroleum, in case there's any confusion. And then it would be of type fossil fuel. So, but it's not that. It's an int, which kind of means integer, and so it returns an integer, an int, 0. And our input is it. Right now we don't have any input. I pointed this out here. This is for having input, and it looks a little complicated because basically it's like almost like anything goes. You could have an arbitrary number of inputs of different types. That's why this looks very complicated. So don't worry about it for now. Right now we have no input to main. That's what we want for now. Okay, so we have this main function and it does something. I don't know why I have all this white space up here. Mostly in the C programming language, white space doesn't do anything. White space is these new lines, spaces, tab, all this kind of stuff. If you have a lot of it, you can select everything and it kind of shows you. Can you see, like, it shows that there's tabs. You can also probably go into like view and show white space. Let's see, appearance. Every editor has some kind of way to show white space, but I probably have to go into settings here, and I don't want to do that. So easier just to select and sort of notice. It's really not important. So in C, oh, and I have a problem here. I got rid of a semicolon somehow. in general, the white space doesn't matter. That's not true for every language. Python, for example, the white space matters. And at first, when I learned Python, because I came from other languages where it didn't matter, that was very annoying. But over time, I realized that this kind of strictness on the white space in Python, it made it so that my Python code always looked better than everything else I did. But anyway, in C, there's a lot of flexibility, so it's just something I have to mention. But you can't... actually, I think doing like this is fine, actually. But it looks ugly, so I never do that. It's probably okay. Yeah, in general, there might be exceptions, but in general, C doesn't care too much about white space. There are other types of white space. There's maybe like 5. There's like weird things like carriage returns and stuff. Don't worry about it. Just know it's a thing. But here, obviously, we have tabs. Sometimes tabs are actually 4 spaces or 8 spaces. It depends on the editor. Will this run you into trouble at any point? No, unless you're doing Python. But in C, this will not be a problem. Also, because the white space doesn't matter, we could just put all this. We could just put all of this on one line like this, which is terrible to read, obviously. So people don't do that. But let's verify that this works. Let's also return a different number than 0. Let's return the number 2. So this is review. We're compiling like this. Okay, and I'll just ls to show you. Now it created this executable. We run it like this. The dot is the current directory. The slash is just like, the slash is what always separates directories and stuff, right? Or it's saying like in the current directory, there's this a.out file. Enter, and it ran, but it doesn't output anything to the terminal. I keep saying that, and I probably will continue to say that. The technical terminology is that it's not outputting anything to standard out. So that will come up. Don't worry about it. But it didn't output anything yet. But it did return a number. We just can't see it yet. And we need this magical command to see what it returned. We push enter, and we get our beloved 2 that we typed in there. So you can see I've demonstrated that having it like this still works. And in fact, we can go even further. I don't recommend doing this, you know, but I just want to demonstrate. You can do this. It should be all fine, even like this. We can get rid of these. We can have everything on one line. It's awful to read. I'm going to remove a.out in case it causes any confusion. Clear ls, doesn't matter. gcc main.c /a.out echo $?2. It worked. Cool. I'm going to control Z to undo all that shenanigans because that is extremely ugly to read code like that. So what are we doing here? What is the chemist doing? We're creating an integer, int. Hello, Koifish. Welcome. Just recording here. We're creating an int and setting it, we're calling it x. So it's a variable of type int, which is an integer. So we can do negative numbers. That's totally fine for int. They get pretty big. You can go up to like plus or minus 2 billion something before you start running into problems with the size of int. There's some restrictions, and you run into what's called overflow. So that will be a topic for later. This is still a pretty beginner level. We're not going to talk about it. So we're creating a variable called x that we're setting equal to 3. Remember, this is not a mathematical equation. This is an assignment. It takes what's here and sort of chucks it over to the left over here. It's almost like it's going from 3 here, wherever x is. That's basically what's actually happening. So it's an assignment. So every time you see an equals sign in a programming language, that's how it works. It's an assignment like that. It goes like it's moving from here to here. That's different from an equation, right? Y equals 5. So a program runs in memory, which means it runs on RAM. RAM is very fast. It's like the speed of electricity, essentially. Whereas storage, like hard disks, for example, is far slower. It's many times slower than RAM. So, yeah, generally things are running in memory, okay? Unless later on we'll see you can do file input output, writing to disk, writing to a file, that's actually saving something to storage. That's a different thing that we'll have to explicitly learn. Everything here happens in memory. So, and that's generally true in programming in general. Pretty much anytime you learn a programming language, you're pretty much doing everything in memory in the beginning. So somewhere in memory, the compiler writes instructions that are in machine code. I'll later maybe do a lesson on sort of the real nuts and bolts of the computer, what machine code is, what assembly language is, what bits and bytes are, what RAM is, what the CPU and the GPU are, that kind of sort of basic computing knowledge that is going to be useful at some point. But I don't want to get into all that too much right now. But I do want to say we're in memory here. The compiler writes machine language code, which is a bunch of ones and zeros that the computer knows how to read, how to execute. And so what this will do is it will create a byte in memory, which is a little tiny space in memory for X, and it will put the number 3 in there. Now it's going to be in binary, actually. So the actual way that stuff is stored, and here I'm writing a comment. I can add anything here. Talked about that earlier. So it will be stored in binary, which means let's say it's a byte. It roughly looks like this. There's a technicality here that makes it slightly different. But let's see if I get this right. It's like this for 3. It's binary. It's going to be all ones and zeros. I don't want to talk about it too much again, like I said, because we'll get into the nitty-gritty details later. But if I were counting in binary, this is 1, this number is 2, then this is 3, this would be 4, this is 5. That's how binary works. So it's different. So that's how a number like 3 is actually stored. And did I set up a new PC in the place I'm in? No, same I've been using the whole time. So yeah, there's 8 bits. A byte is 8 bits. Usually, okay, this is not 100% true what I'm about to say, but usually when we're programming, we're manipulating a byte at a time. Usually, there are ways to manipulate individual bits. That is more advanced. We'll probably get to it at some point. But in the vast majority of contexts, you don't need to manipulate an individual bit at a time. So it's just sort of a convention, a standard that how data is organized on the computer, we usually think in terms of bytes. It's 8 bits, which can store a certain amount of information. At least that's, well, yeah. I mean, that's just the real super basic version. There's more complicated stuff to talk about. I mean, you can have these ints, I think are, yeah, they're actually 32-bit. So they're actually 4 bytes. But the most basic thing that we're going to manipulate is, for a long time, is going to be a byte. Yeah, so that was confusing, the way I explained all that. Just remember that a byte is 8 bits. And later we'll talk about different sizes of things and that these are actually 4 bytes or 32-bit. You can also have 64-bit numbers and all that kind of stuff. So you just have different sizes of things. Don't worry about it now because we're just dealing with small numbers, so it really doesn't matter yet. Okay. Now we're declaring an integer we just call it out. You can call it whatever you want, But then I'd have to switch this. Because when the compiler sees this out here, I haven't declared it. So it won't know what to do with this. Another language like Python, if it were Python, it would look at this and be like, oh, you're making a new letter or new variable. Okay, fine. But that's not really a great way of doing things, because suppose I just made a typo. So suppose this is out. It's declared here, no problem. But here I accidentally just type another T. If it were Python, it would say, oh, it's a new variable. But actually, I just made a typo. So you see, it's kind of better that it's more explicit that we've declared. We're making a variable and we're calling it out. Now here, just in this line, it has no value there. So the program goes line by line. Now what's kind of confusing here to a newbie is that I'm mixing two different ways of doing things. Here I'm creating a variable, we say declaring, but we're creating one, and I'm assigning it in one line. And I do the same thing here. Here I'm doing it in two separate lines. It's just two different ways of doing the same thing. Here I'm declaring and then I'm assigning. So I don't have to do it like that. I can just as easily go like this. Same thing. Declaration and assignment in one line. So again, declaration is just the creation. So right now there are 3 places in memory. One of them has the number 3. One of them has the number 5. One of them has the number 0. Technically, they're all stored in binary. Here, 0, that's easy in binary. It's like that. No problem. That's simple. Again, we'll worry more about binary and stuff like that in the future. I don't want to make it too confusing right now. Now we have a line here where we're setting out equal to x plus y. Remember, this is not an equation like in math class. It's basically taking whatever's here, it evaluates this expression, and then puts it in memory wherever this is, wherever this variable is. So what was previously 0, and I'm just using this is not correct C code, I'm using this as an explanation. It's moving it from here over there. So it goes right to left. So again, not an equation. So after this line is executed, the space in memory corresponding to this variable will have whatever the value of x plus y is, which happens to be 8, right? Yeah. I almost should maybe draw some pictures at some point. But we're probably going to be drawing pictures once we get to pointers later. So I'm not going to draw pictures now. Just imagine there's 3 spaces in memory. So this line does not create a new space in memory. Doesn't need to. We already have out. Just computes these. And now we're not using out for anything. We're returning 0. So we could return out. That would be cool. And I did this in the last one, but let's just compile this and run it. Echo. We get the output like this. My camera died again. And we got 8, which is what we expect from here. Okay, so that was basically all review. But I just think for beginners, it can be important. Now we're going to get a little more complicated, and I'd like to introduce a loop. And so what I'm going to do, let's make a new variable called I. And let's set it equal to 1. Okay. And okay, I'm going to get rid of this line that does the output here. And okay, so just bear with me. I'm going to write some stuff and then I'm going to explain it. We have a little new block of code where we can do stuff. Now I actually can just put a semicolon here and this line now does nothing. And don't do this. Can I do this? So this is a while loop. And if I put true here, so whatever is in these parentheses, it loops as long as this is true. So for example, let's put in here out equals out plus x. Okay. So because this is true, it will loop. Meaning it will repeat what's in here as long as this is true. Well, I wrote that it's true. So this is always going to be true. It's always going to be that way. What that means is this is going to keep looping forever, and our program is never going to stop. You don't want that. Now, I could also put here false. Then this will never run, not even once. Alternatively, I can put in 0, which means the same thing as false. I can write in the number 1 we often use for true. And I think, I'd have to look it up. I think even just like anything that's not 0, like even like a -1, might evaluate to true. But I think it might be a bad practice. So kind of don't think about that right now. Just think 0 is false, 1 is true. It's like an off-on switch kind of thing. So we could do that. That would be very simple. And also very useless. So what I would rather do, I'd rather add another line here. That I equals I plus 1. And in here, I'll put I is less than, or let's do less than or equal to 10. Okay, so I'll explain what this does. This is going to loop through here 10 times. But how do I know that? So the while loop checks what is in here. This is called a conditional. So it checks the condition. And it wants to find out if it's true or false. So we're going to walk through this code logically, step by step. So we did these. We talked about what these do. Okay, we already have that. We get to here. It creates a variable called I and puts the number 1 there. So I is 1. Basically there's a space in memory called I, and it contains this number 1. Okay, it's like a little box. So, okay. So it's incredibly pedantic, but I'm just going to write space in mem. Well, I is set to 1, all right. Just because we don't have that much space. Value of 1 goes to space in memory called I. Very pedantic. I apologize if this is like crazy obvious for some people, but I'm just thinking that some people might be learning programming for the very first time. So while I is less than or equal to 10, so what it does, first we've created a space of memory that we call I. We've put the number 1 into that little box. Now we go to this loop. So we're looping, meaning we're running some code over and over again, but we need to figure out how many times we run it. We look to this conditional statement. This determines if we run the block or not. We call this a block of code. If it's inside of some curly braces like this, it's a block. So all of this is a block of code. This is a block of code. So when we look at this conditional, first, I is equal to 1. So is I less than or equal to 10? Yes. So that evaluates to true. Okay, it evaluates to true, which means we entered the loop. That's right, some people are really new at coding. Yeah, definitely. Absolutely. And so out equals out plus x. So what happens here? Well, out is 0. But remember, it's not an equal sign. It evaluates the right hand first. Okay, so I'm going to write a comment. So right hand evaluates first. Out plus x. So this is going to change though, so I don't want to write it first. Or I don't want to write it out. It will be 0 here plus 3, right? What is 0 plus 3? It's 3. So this is saying out equals 3. I know that might be a little confusing that you have out on both sides, but it will take out and change it to, it will, like, out is a little box in memory, and we're putting 3 in there now. Then we do a similar thing here. I was 1, so again, we do the right-hand side first. I is 1. 1 plus 1 is 2. So the box where there's I in memory, we put a 2 in there. So now I is 2. Gets to the end of the loop, but it goes back and it checks here again. So now I is 2. So it checks here. Is 2 less than or equal to 10? Yes, that's true. Therefore, it enters the loop. So we go in here again. Now out is still 3. That's what happened last time. So 3 plus x, which is 3. So now that's 6. So the box that we call out, we put a 6 in there. So out is now 6. I is now 2, if you remember. So 2 plus 1 is 3. So the I box, we put a 3 in there. We get here, and it goes back to the beginning, and now it checks. I is now 3. So is 3 less than or equal to 10? Yes, it's true. So you can see that we're going in a loop, and eventually I is going to be equal to 10 at some point, right? I keeps increasing by 1 each iteration of the loop. Each time we go through the loop, it increases by 1. So eventually, so this will actually, if you work it out, and to people who are really new, you might want to stop and like walk it through it in your head. You can choose an easier number too. You could choose 4, for example, and then there's less stuff you have to work out. But this is going to go through 10 times. Okay, so if we return out, what do we expect? We expect that it started at 0, but we added 3 10 times. So we should get 30 here, unless I made some kind of silly mistake, which is possible. I often make silly mistakes. So let's compile. Also, make sure, if you're using VS Code, make sure that you save. So if I like create a new line, you'll see this dot here. You always have to do Control S to save it. If you don't save it, you're gonna be compiling the older version. That's a very common mistake for beginners. So we're gonna run the compilation. Nothing comes, but we do this magic command and we get the output, which is 30. That's what I expected. So so this is a while loop. There are several types of loops in many different languages and also in C. It turns out, and I didn't know this until a few years ago, you can actually pretty much do everything just with a while loop. You don't actually need the other loops, to be honest. And the while loop is actually probably simpler than everything else. So we can actually get quite far with a while loop. There's other loops, like there's a do continue loop, and there's a for loop, and there might be some others that I'm forgetting right now in C. But yeah, we can actually pretty much do everything we want with a while loop. So yeah, so if you're looking online and you see about for loops and all this kind of stuff and it's confusing, I mean, read it if you want, or if you just want to follow with what I'm doing, we're going to just use while loops for a while. Okay. So just for practice, so if this is less than or equal to 3, and let's do y instead, plus y, what will this do? Well, I'm going to go a little quicker. People can pause and think if they need to. But this will go through the loop 3 times. And so out starts as 0. We add y to it 3 times. So we should get 15 here. So let's compile, run the executable binary program, whatever you want to call it, echo out, and we get 15. So that's what I expected. Okay. Now I want to make things a little more complicated. Let's start at 0 and change it to less than. So this will still iterate 3 times. Why? Well, before I was starting at 1 and then saying less than or equal to 3, and it went through 3 times. I'm just decreasing both of these by 1 in a sense, because I'm saying instead of less than or equal to, we're going to do less than, and instead of 1, we're going to do from 0. And this is actually the way that programmers normally write these kinds of loops. Some people who are beginning, they say, why would you start counting from 0? But almost every programmer counts starting from 0. It's just this weird thing that we do. So you just have to get used to it. Actually, Lua, they typically start counting from 1, but that's the only one I know where they don't do that. Everything else I know, people start counting from 0. So you kind of have to get a hang of that. But if you start at 0 and then you do less than 3, just kind of get used to the fact that this is going to go through 3 times. You just kind of want to remember this pattern because you're going to see it over and over again. But in the beginning, this is going to be a little confusing. That's just the way it goes. So this will go through 3 times. And, I think this is maybe enough for the lesson today, to be honest. Just doing while loops. We've got some arithmetic and stuff going on. We could multiply stuff as well. So let's say if I started with 1. Before we multiply, let's do one more thing. Instead of writing I equals I plus 1, people often write, you can just write I plus plus. It does exactly the same thing. It just increases the thing by 1. However, so I want you to remember that. We're going to use that in the future. But just because that can be confusing to beginners, I think, I'm just going to leave it like this to keep things less confusing for now. Let's use multiplication instead. So I'm going to start with 1 here. We're going to iterate. Let's iterate 4 times. This is going to do 4 iterations. And we're going to do out. And let's do times y. So we should get, it's going to multiply, that's actually a lot. Let's just do twice. Let's do 3 times. So this is going to be, it's going to go through the loop 3 times. So we start with 1. 1 times 5 is 5. Second iteration, it's going to be, this is 5. We're going to multiply by 5 again. So we get 25. Third iteration, this is going to be 25. It's going to get multiplied. I should say this is going to be 25. It's going to be multiplied by 5 again. We get 125 for the output. That is what I'm predicting, unless I made some silly logical mistake. 125. So I think that's enough for today. Let me just quickly take a glance here. Oh, we should very soon talk about printf, because with printf, that'll probably be next lesson, but we can, instead of always doing this like echo thing to get the output, our program will directly output to the terminal. So that's sort of more convenient and more common. So pretty much every computer language has some kind of print statement. In C, it's a printf statement. The F stands for formatted, and you have this sort of weird stuff going on. That's for formatting, okay? So that's why it looks weird. This is saying formatted as a decimal number, but we'll talk about it more in the future. But I think it's good to sort of to throw out some things that we're going to learn in the future so that it doesn't come as a complete shock. Like you get some I don't know, anticipation or what's the word? Foreshadowing, I guess. Final Fantasy VII. Oh yeah, the description. I forgot to update it. And so that print function actually is going to require this header. So we'll be talking about that in the future. This is stdio is standard input output. So this is all of these are extremely common headers that we use. It basically gives us more functions, more power, more things that we can do. We'll talk about it more. So for example, this printf, if I write this but I don't include the header, a lot of times your program will not compile. Now, actually, our compiler that we're using, it will see the printf and realize, oh, this person wants to use printf, so they'll include it for you or something. Unless you do use the more strict, what are they called? Options, compiler flags they're called. They're basically options. If you use these more strict ones, it will not compile for you. So whether that's good or bad is debatable, but I think it's better to, to be including things correctly. So I think it's better that it actually just crashes, or it doesn't crash, it doesn't compile for you. Okay, so we're going to be learning about that. This scanf thing is actually for, we can type in input into the terminal that our program will use. We'll probably talk about that at some point. A char is meant to correspond to like an individual letter. Char is character. We'll talk about that at some point. But you can see it's a little confusing because it can also be, you can also use integer values with it, so it's a little weird, a little wonky. We'll have to learn that. Floating numbers basically means decimal numbers, so like a number like if it were like 0.3 or something like that, sort of fractions, that's what a float is. And we'll talk about all this stuff. These are like just I mentioned the size of things, like there's bytes. The ints that we're using are actually 32-bit, and these are much bigger. These are I'm not even sure. It's at least 64 bits though, and double, I think, yeah, it's usually 64-bit. These are kind of details. Like I almost never bother using long or double. This is for like much higher accuracy, which I never actually need. But floats are used all the time. So those are basically the idea. The reason it's called floating point is the idea is that this is the floating point. It's the decimal point that can sort of float around. That's the image we've got here. And this is like all programming languages. They pretty much all have floats. Yeah, and probably the stuff after here is probably going to be much later. So there's all kinds of stuff that we need to talk about. And I think it's very interesting. And you can see we're not even halfway through this document. But this contains a lot of information here. So people who know other programming languages already, you can come to this learn X and Y, and you kind of have this quick overview where you can learn quite a lot of stuff quickly, which I think is nice. But I'm going to go through things very gently, very slowly with beginners in mind. And yeah, so in this one, we did some review of the shell, the terminal, that kind of stuff. And so more and more, it's going to be primarily C. You're going to see less shell, less terminal. But I don't know. I might divide it up. I might make some videos for more shell commands and stuff. And if you want to learn more shell commands, you can Google like, let's say like terminal cheat sheet, for example. People make lots of these, and you'll learn. First of all, there's lots of stuff, lots of videos and blog posts and all kinds of things telling you like all the cool commands that you should know how to use, and you can find all these cheat sheets everywhere, lots and lots and lots of them. But I think I'm trying to just introduce things kind of slowly. But let's see here if I can get this up. 1 second. Let me bring this up. Hold on. Oh, it won't let me do it. Grr. It won't let me do it. Sorry. All right. But you can see they mentioned some of the stuff that I taught already. PWD, CD to dir, CD ... CD dir just means like you type in some dir here, some directory, some folder. I know it's really small. Can I make it bigger? PWD, make dir, CD, we've talked about ls, we've talked about there's a bunch of ls options. I've talked about some of them. And all this stuff we haven't talked about except man, for the manual pages. You can get your uptime. Who am I shows your username. Date shows the current date. Mount shows mounted file systems. So you might have multiple hard drives, for instance, or if you put in like a thumb drive, it will pop up it might pop up there. If you're using WSL, it's a little more complicated. If you had installed a Linux system from scratch, this would do that. So, I mean, this is more advanced usage stuff. More advanced show system and kernel, whatever. I've talked about Control C, that if you have some kind of process that is not stopping, this is very important to know so that you can exit that. I don't think I really never use this other stuff too much. Repeat last command is kind of nice. I usually don't use it, but I kind of forgot about it. I used to use it for a while. And some more advanced stuff. Again, I might make some dedicated videos. Stuff like path. Let's see. Yeah, if you're on a Mac, it's definitely useful to know some of these more advanced things about path. So this is an environment variable, which tells you it's important. The path is where this is needed. For example, when I type in all these commands like ls, rm, make dir, cd, it actually finds these binaries by looking in the path. The path tells the machine where to look for commands. So when I do this code thing, which requires some setup, this makes use of the path, actually. So if I can, this is more advanced, don't worry about it too much, but I can echo my path. We'll just pop out my path. It's a mess. But yeah, don't worry about it right now. It's more advanced, but it's sort of important. Yeah, I'd say it's kind of important. So there's some more advanced stuff to learn. We've talked about touch for creating files, although I talked about it. I talked about it in the last video. We've talked about cat. We talked about CP. I haven't talked about MV, so that's important. That's just moving files rather than copying. RM we've talked about. These aren't so important. Then it's more advanced. There's pipes. That's pretty advanced stuff, but really powerful. This is like process management, so it's kind of like using your task manager on Windows, or on Mac there's activity monitor. You can kind of do this kind of stuff from the terminal. That's more advanced. I probably won't touch on it more than just like telling people that you can find these kind of cheat sheets with all this stuff. Chown and chmod, these are related to permissions, so that's sort of intermediate level, but it's actually important. I don't bother with this stuff. This is for having multiple sort of dividing your screen into multiple screens, if you will. Like the terminal window, you can actually divide into multiple things. There's a better way to do that than this, called tmux. Again, more advanced. One important thing is I didn't mention how to copy paste. But yeah, we've done most of the stuff. If you want to dive into this stuff, look at a few of them. They'll have different things there. So if you want to copy paste, you actually need to do, at least on my system, Control-Shift-C. And then just the normal Control-V. And if you want to go the other way, Control-C is copy, and then you actually right-click. So that is annoying in the beginning when you don't know it. So again, Control-Shift-C. And then right-click to paste. Okay. Yeah, I think that's good enough for today. So you can see I really did I did all of these, right? That's important. grep is advanced. It's for searching for keywords. Find is for searching for files or directories. Yeah, anyway. There's more advanced stuff. Probably put that in separate videos. And then C itself, actually, obviously. So leave any comments letting me know, questions, any kind of feedback is going to be extremely helpful. And hope you have a fantastic rest of your day. And if you've made it this far, like helps me out big time as well. So thank you and have a good day. Bye. Just gonna wait a bit because the stream sometimes takes some time. Bye bye. Thank you. Bye bye. Wukong. Wukong. Maybe. Looks cool. If I have time, I'll try it. Alright, I'm signing off. Thanks, Koi Fish, for hanging out. Bye-bye, everyone. Happy coding.